Thank you. Good afternoon, everyone. Always happy to be here. So today I will present the RAMSES mission, which is under study at the European Space Agency. RAMSES stands for Rapid Apophis Mission for Space Safety. So before going to RAMSES, I'd like to show this slide, which reveals the incredible diversity of asteroids, as you can see, with different kind of shapes, of sizes. Composition does not reflect here, but densities. We even have many binaries now. But what is really exciting and also intriguing is that we now know that images do not necessarily tell us the mechanical response of an asteroid when you touch it. And this is, of course, very important for planetary defense, because if we send a spacecraft to deflect an asteroid, we want to know what would be the response. And when you see those images, you could think, okay, we have a lot of boulders, so the surface will have some strength, and therefore it will be hard to resist to any action. And in fact, the recent missions like OSIRIS-REx or Hayabusa 2 told us that these images can be misleading, because even though the surface looks like a solid, in fact, when you touch it, it behaves like a cohesionless surface. Not like a fluid, but almost like a fluid. So basically, with the OSIRIS-REx touch-and-go sampling mechanism, when it touched the surface, there was basically no reaction of the surface. So that shows that we still need to interact with those bodies if we want to better understand their behavior, and if we want eventually to relate images to the actual mechanical response of these bodies. So the great thing is that on Friday 13th, April 9, 2099, nature does the job for us. It interacts effectively with an asteroid through tidal forces. So we don't even have to make an interaction ourselves, which has always been what we have done so far with a sampling tool or an impact. This time we just go there, we observe how tidal forces influence the property of an asteroid. And this is spectacular. This is something that happens only once every millennia, so it's our only occasion to see that happening. And this is so exciting that we have the UN resolution that 2029 is now the asteroid, the International Year of Asteroid Awareness and Planetary Defense, because effectively this is really the great opportunity to tell the world what we're doing, first to tell that Apophis will miss the Earth, and then observe what happens. So because of that, the European Space Agency started development, waiting for formal approval at the ministerial in November 2025, of the RAMSES mission, which aims at arriving at Apophis before the close approach, measure its initial properties, observe how they change due to the influence of tidal forces, and therefore tell us about the behavior of these objects in their natural environment, which is really exciting. So there will be all the measurements that are shown here about the physical and compositional characteristics of the object, including the shape, the rotation axis, internal properties, surface properties, etc. And that will be done before, during, and after the encounter. And also something very interesting, that we will take images of the asteroid during the closest approach, and we will feed them to the public, while more than 2 billion people will see the light with naked eyes in Africa, in Nice, and in other countries that are in Europe and basically Africa and part of Asia. So I can imagine a child looking at the light in the sky, and then on a screen, the real images of the asteroids. This is really absolutely exciting. So to do so, of course, we have to launch very quickly. You will see in 2028, so there is only 3 years left. So that's why, in order to be ready, we basically use the heritage of Hera and essentially rebuild the platform of Hera, adapted, of course, to the case of Apophis. Apophis come closer to the Earth than Dimorphos and Didymos, so you need a smaller antenna, smaller solar panel. However, you have a higher delta V, so you need a larger tank. So it's basically an adaptation of the Hera platform, which, by the way, was built in only 4 years. So it's already really a great milestone. And so now we use it to build another spacecraft, this time in 3 years, basically. There is, as you can see, a median antenna and a smaller solar panels. We also have international cooperation, in particular with JAXA. JAXA is providing a thermal infrared imager, the same as on Hera. Also solar arrays, And there is a discussion that they could provide also the launcher A3 to be confirmed. And there is a synergy with the Destiny mission, which is a Destiny Plus, which is a mission that aims at the flyby of Phaeton, you know, this active asteroid, but on its way, it should do a flyby of Apophis, in principle, before RAMSES arrives. So that would be great because we could have a better informed shape model to start with when RAMSES arrives, saving time for the close proximity operations. And with NASA, as you will see in the next talk, there is also an amazing mission called OSIRIS-APEX, and we are already discussing with APEX to have a synergy between the two missions. In terms of mission profile, so the launch will take place in the spring 2028 with a 10-month direct transfer to Apophis. So basically, the mission will start really at the end of February 2029, about 2 months before the close approach of Apophis, and then there will be a series of trajectories leading us to the closest approach, where we'll be do hovering and therefore observe the changes, and then go back to hyperbolic orbits, and with a mission nominally ending in August 2029, but we may also be extended depending on how it goes. These are the core and opportunity payloads. So at the core payloads, we have the one that we are already ready, basically the cameras and the radio science, of course, for the mass determination, accompanied with inter-satellite link, because we have 2 CubeSats like on Hera, and using the link, the communication link between the CubeSats and the spacecraft, you can better measure the trajectory of the CubeSat and the influence of the gravity of the asteroid and enhance your knowledge of the gravity field. So out of these 2 components, cameras and radio science, we have other payloads that have now been selected by ESA. So there is, of course, the thermal infrared imager. I talked about it by JAXA, laser altimeter. We have also Hamlet, which is the same as the Hyperscoot imager on Hera, but extended to longer wavelengths. So this is nice because we can see the 1 micrometer band, which is a characteristic of silicate minerals and characteristic of S-type asteroids. We have also another high-resolution camera in the middle range with colors. And we have something quite original, which is a sort of a plasma spectrometer. You would wonder why we use a plasma spectrometer of an asteroid. Well, why? We don't know. That's why we put it. In fact, we come within the Earth's magnetosphere, so there may be some effect of the magnetosphere. You know, there is a theory that maybe it can cause dust levitation that could explain why some asteroids look fresher when they come close to a planet. Don't ask me more, that's all I know. And then we have 2 CubeSats. So one will carry the low-frequency radar that Alain just talked about, as well as a dust detector and analyzer, which is also on Hera. As you see, we really use the heritage of Hera. And the second CubeSat is planned to land. This is under study. This is to be confirmed. And will then carry a seismometer, a gravimeter, and a magnetometer. And this is absolutely exciting because we have decades of seismology studies on the Earth, on the Moon, on Mars. We never did it on an asteroid, and this would be the first time we measure how the seismic waves propagate into an asteroid while it vibrates against the tidal forces of the Earth. So this is really exciting. And if you combine the measurement by a seismometer with the measurement by the radar, which both have some degeneracies, then you have a better, even better knowledge of the internal properties of the asteroid. So that's going to be absolutely exciting. Close proximity operation, we have different epochs where we will do some hyperbolic arcs in different ways until we hover at low distance, 1 kilometer, and then go back at 5 kilometers. So these are the series. I can show you a few examples of these kind of arcs where you see the asteroid and you see here these hyperbolic arcs that we start to do that allow us to get a surface covered with a resolution of only 1.2 meters. Then we have a bow tie, what we call bow tie hyperbolic arcs. We even reach a higher resolution, less than 1 meter. And finally, we have hovering with simultaneous science and Earth communications that could feed in live the images to the public. So in terms of programmatic status, the contract with the OHB Italy The industry was signed at the last International Astronautical Congress in Milano. That was in October last year. So there was a successful PDR already done in January. And then we have the 2 CubeSats, which are going through SRR, one by TIVAC, also in Italy, and the other one by MXIS in Spain, with also a GomSpace contribution. So this is going nominally, and as I said, there was a pre-funding phase that was approved because we couldn't wait the Ministerial Council of ESA in November this year to start the development to be ready in 2028. So the member states kindly agreed, those who contribute, kindly agreed to already put some money on the table to start the development until we have formal approval in November. So these are the master schedule where you have the PDR that was already passed. We have a CDR that will go across the Ministerial Council in November. Spacecraft integration up to December 2026. Qualification acceptance review in first quarter of 2028. And then the launch in April, March 2028 to arrive at Apophis in the end of February 2029. As a comparison, I had put a little square the development of Hera as a reference, and you can see that we squeeze even more the schedule in order to be ready. But as I said already, Hera proved to succeed to develop something in a very, very, very quick time. So we are very confident that this can be done within the time, and with a project team led by Paolo Martino at ESA, it's absolutely fantastic, do a lot of work, and we are super excited and confident. Another thing is international cooperation. This is very important. We have demonstrated with DART and Hera that we are happy to work together. So Hera is now on its way, and so we can do the same. In this case, a little opposite. So the ESA arrived first at Apophis, and then OSIRIS APEX, that will be presented just afterwards, come just after, and we can have a sort of a continuity between the measurements that can extend over a long time scale. And this time we would have Destiny Plus maybe arriving first, then RAMSES and APEX, and maybe other missions. There will be an Apophis session later today. You will see that there are a lot of other projects that are planned to go, which will require that we coordinate very well so that we don't crash into each other. But again, I'm confident we can do it because we enjoy working together. So in conclusion, I would say that RAMSES is a way for ESA to demonstrate a very rapid response, which is one of the objectives of planetary defense. For the second time after Hera, we have a deep space exploration of an asteroid with not only one spacecraft, but a mother spacecraft and 2 CubeSats that operate together in order to enhance the science that we can do that feed into planetary defense. We have promising synergies with at least OSIRIS APEX. Already we are coordinating Destiny Plus and possibly other missions. We have contributions from international partners. We have also a great science return over a very rare event that will allow us for the first and maybe only time to observe the natural behavior of an asteroid under natural forces. It's absolutely spectacular. And of course, a great opportunity for public outreach because, as I said, having missions there while people are looking is not only good for the inspiration, for the science, but also for the message that, we always work together internationally, and this is very important regardless of all geopolitical tensions. With this, I will thank you. I just finished by showing you what won't happen. This is a simulation that we did with my former postdoc Yun Zhang about a tidal encounter, but this time by 3 Earth radii. This is a rubble pile, and if this happens for Apophis, that would be super cool, but that won't happen. Let's see. We turn an asteroid into a sausage, basically. Okay, thank you.